When selecting an AutoCAD-compatible Windows-based program, consider several alternatives. Firstly, CAD is a full-featured alternative to AutoCAD, offering similar functionality and a user-friendly interface. Secondly, DraftSight is a free and lightweight option for 2D drafting. Thirdly, LibreCAD is an open-source program with a similar command structure and user interface to AutoCAD. Fourthly, TurboCAD is a comprehensive CAD program with advanced 3D modeling capabilities. Fifthly, Vectorworks emphasizes building information modeling, known as BIM, for design and drafting. Sixthly, CAD provides a cost-effective AutoCAD alternative with a wide range of features and compatibility. Seventhly, QCAD is a free and open-source CAD program supporting both 2D and 3D drafting. Eighthly, NanoCAD is a compact and inexpensive option suitable for basic drafting tasks. Ninthly, MicroStation is a powerful CAD program tailored for civil engineering, geographic information systems, and plant design. Tenthly, Allplan is a specialized CAD program designed for architectural and engineering projects. Upgrading to a modern CAD program offers several benefits. Firstly, enhanced functionality. Modern CAD programs offer a wide range of advanced features such as 3D modeling, parametric design, and BIM support. Secondly, improved productivity. User-friendly interfaces and automated tools can significantly increase efficiency. Thirdly, file compatibility. All the programs listed above can import AutoCAD drawings, ensuring seamless integration with existing work. Fourthly, support and updates. Windows-based programs provide ongoing support and regular updates, ensuring access to the latest features and fixes. Consider the cost savings. Some of these programs, such as DraftSight and LibreCAD, are free or low cost, offering a cost-effective solution. When evaluating these programs, it's important to consider specific needs and project requirements. For example, if the primary focus is on 2D drafting, DraftSight or LibreCAD might be suitable options. For more complex 3D modeling and BIM workflows, BricsCAD, TurboCAD, Vectorworks, or Allplan could be better choices. Compatibility is crucial. Ensure that the chosen program can import and export DWG files seamlessly to avoid data loss or translation issues. Take advantage of trial versions to test the software's capabilities and user interface. A trial period allows hands-on experience with the program's features and helps to determine if it meets specific needs. Consider the learning curve associated with each program. While some programs have interfaces similar to AutoCAD, others might require additional training to become proficient. Evaluate the availability of support resources, such as online documentation, tutorials, and user forums. Access to comprehensive support can be invaluable when encountering technical issues or needing guidance on specific features. Check for compatibility with other software or hardware currently used. Ensuring seamless integration with existing workflows can streamline the design process and avoid compatibility problems. Review user reviews and ratings to gain insights into the experiences of other professionals using the software. User feedback can provide valuable information about the program's strengths, weaknesses, and overall reliability. Explore the program's customization options. The ability to customize the interface, commands, and settings can enhance productivity and tailor the software to specific preferences. Investigate the program's capabilities for collaboration and data sharing. Efficient collaboration tools are essential for working on projects with multiple team members or external partners. Look for features like cloud storage, version control, and real-time collaboration. Evaluate the program's performance on existing hardware. Some CAD programs can be resource-intensive, requiring powerful computers with ample memory and graphics processing capabilities. Ensure that the system meets the minimum requirements for the chosen software. Consider the long-term costs associated with the program. While some programs are free or low cost initially, they might require ongoing subscription fees or upgrade costs. Factor these expenses into the overall budget. Explore the program's capabilities for automation and scripting. The ability to automate repetitive tasks and create custom scripts can significantly improve efficiency and reduce errors. Investigate the program's integration with other design and engineering tools. Seamless integration with software like finite element analysis programs or manufacturing software can streamline the design to production workflow. Check for compliance with industry standards and regulations. Depending on the specific field, the CAD program might need to comply with standards like ISO, ANSI, or SME. Ensure that the chosen software meets these requirements. Evaluate the program's capabilities for generating reports and documentation. The ability to create detailed reports and documentation is essential for communicating design information to clients, contractors, and regulatory agencies. Consider the program's support for different file formats. In addition to DWG, the software might need to support other file formats like EXF, DGN, or PDF. Check for compatibility with these formats. Explore the program's capabilities for managing large and complex models. Some CAD programs are better suited for handling large assemblies or models with many components. Ensure that the chosen software can handle the complexity of projects. Investigate the program's features for clash detection and interference checking. These features can help identify potential conflicts between components or systems, preventing costly errors during construction or manufacturing. Check for support for different coordinate systems and projections. Depending on the type of project, the CAD program might need to support different coordinate systems, such as geographic coordinates or projected coordinate systems. Evaluate the program's capabilities for generating 2D drawings from 3D models. The ability to automatically create 2D drawings from 3D models can save time and reduce errors. Consider the program's support for different types of annotations and dimensions. The software should provide a wide range of annotation and dimensioning tools to accurately convey design information. Explore the program's features for managing layers and object properties. Efficient layer management is essential for organizing and controlling the visibility of objects in the drawing. Investigate the program's capabilities for creating and managing blocks or symbols. Blocks and symbols can be used to represent repetitive elements in the drawing, such as doors, windows, or electrical components. Check for support for different types of line types and hatch patterns. The software should provide a variety of line types and hatch patterns to visually differentiate between different objects or materials. Evaluate the program's features for creating and editing splines and curves. The ability to create and edit splines and curves is essential for designing complex shapes and surfaces. Consider the program's support for different types of surfaces and solids. The software should provide tools for creating and manipulating surfaces and solids, such as extrudes, revolves, and lofts. Explore the program's capabilities for performing Boolean operations on solids. Boolean operations such as union, intersection, and subtraction can be used to create complex shapes by combining or subtracting solids. Investigate the program's features for creating and editing meshes. Meshes are commonly used to represent complex 3D shapes, such as terrain models or organic forms. Check for support for different types of lighting and rendering. The software should provide tools for creating realistic renderings of the model, including different lighting effects, materials, and textures. Evaluate the program's capabilities for creating animations and walkthroughs. The ability to create animations and walkthroughs can be useful for presenting the design to clients or stakeholders. Consider the program's support for different types of output formats. The software should be able to export the design in various formats such as PDF, STL, or OBJ for use in other applications. Explore the program's features for managing revisions and versions. Version control is essential for tracking changes to the design and ensuring that everyone is working on the latest version. Investigate the program's capabilities for comparing different versions of the design. The ability to compare different versions can help identify changes and resolve conflicts. Check for support for different types of data exchange formats. The software should be able to import and export data in various formats, such as IF, STEP or IGES for interoperability with other software. Evaluate the program's features for managing and tracking attributes. Attributes can be used to store additional information about objects such as material properties, cost, or supplier information. Consider the program's support for different types of databases. The software should be able to connect to various databases such as Microsoft Access, SQL Server, or Oracle for managing and accessing data. Explore the program's capabilities for creating and managing bills of materials. A bill of materials is a list of all the components or materials required to build the design. Investigate the program's features for generating cost estimates. The software should be able to generate cost estimates based on the design, taking into account material costs, labor costs, and other factors. Check for support for different types of simulation and analysis. The software should be able to perform various simulations and analyses, such as stress analysis, thermal analysis, or fluid flow analysis. Evaluate the program's capabilities for optimizing the design. The software should be able to optimize the design based on various criteria, such as cost, weight, or performance. Consider the program's support for different types of manufacturing processes. The software should be able to generate toolpaths and other data for various manufacturing processes, such as milling, turning, or 3D printing. Explore the program's features for managing and tracking changes. Change management is essential for ensuring that all changes to the design are properly documented and approved. Investigate the program's capabilities for collaborating with other disciplines. The software should be able to facilitate collaboration with other disciplines, such as architecture, engineering, or construction. Check for support for different types of project management methodologies. The software should be able to support various project management methodologies, such as Agile, Waterfall, or Scrum. Evaluate the program's features for managing and tracking risks. Risk management is essential for identifying and mitigating potential risks to the project. Consider the program's support for different types of regulatory requirements. The software should be able to comply with various regulatory requirements such as building codes, safety regulations, or environmental regulations. Explore the program's capabilities for creating and managing templates. Templates can be used to create new drawings or projects based on predefined settings and standards. Investigate the program's features for customizing the user interface. The user interface should be customizable to suit individual preferences and workflows. Check for support for different types of scripting languages. The software should be able to support various scripting languages, such as Lisp, VBA, or Python, for automating tasks and extending functionality. Evaluate the program's capabilities for integrating with other software applications. This software should be able to integrate with other software applications such as Microsoft Office, Adobe Creative Suite, or ERP systems. Consider the program's support for different types of cloud services. The software should be able to integrate with various cloud services such as Dropbox, Google Drive, or OneDrive for storing and sharing files. Explore the program's features for managing and tracking assets. Asset management is essential for tracking and managing all the assets used in the project, such as equipment, materials, or resources. Investigate the program's capabilities for creating and managing libraries. Libraries can be used to store and reuse common components or elements in the design. Check for support for different types of data visualization. The software should be able to visualize data in various formats, such as charts, graphs, or maps. Evaluate the program's features for creating and managing reports. Reports can be used to summarize and present data about the design, project, or assets. Consider the program's support for different types of mobile devices. The software should be able to run on various mobile devices, such as smartphones or tablets, for accessing and managing data on the go. Explore the program's capabilities for collaborating with remote teams. The software should be able to facilitate collaboration with remote teams regardless of their location. Investigate the program's features for managing and tracking communications. Communication management is essential for tracking and managing all communications related to the project, such as emails, phone calls, or meetings. Check for support for different types of security protocols. The software should be able to support various security protocols, such as encryption, authentication, or authorization, for protecting data and preventing unauthorized access. Evaluate the program's features for managing and tracking changes to the design. Change management is essential for ensuring that all changes to the design are properly documented and approved. Consider the program's support for different types of regulatory requirements. The software should be able to comply with various regulatory requirements, such as building codes, safety regulations, or environmental regulations.